Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss S parameter equivalent circuit. Let's begin. Here, we are dealing with two-port network system. In case of two-port network system, the number of parameters used to show the properties of that port network system is evaluated by the formula for two-port network. There are 4 terminals. It is represented as 4 combination 2. When we simplify it, that is 4 factorial divided by 2 factorial, 4 minus 2 factorial, that is equal to 4 factorial divided by 2 factorial into 2 factorial. Simplifying it, 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial, 2 factorial, 2 factorial cancel out, 12 divided by 2, which is equal to 6. So, there are 6 number of parameters used to explain a two-port network system. What are the 6 number of parameters? The 6 number of parameters, the 6 number of parameters are first one, Z parameter, Z stands for impedance parameter, which explain input impedance and output impedance for that of two-port network system. Next, Y parameter, that is admittance parameter. Third one, H parameter, H stands for hybrid mix. By using that parameter, we can calculate impedance, admittance, current gain, voltage gain, power gain, like so many features of that two-port network system. Next, G parameter is the inverse of H parameter. Capital A, B, C, D parameter, and finally small a, b, c, d parameter, which is the inverse of capital A, B, C, D parameter. As we know, transistor is a two-port network system. For that reason, we analyze that a transistor by using such number of parameters, but in general most useful parameter is S parameter or hybrid parameter. In that particular video, we have to discuss what is S parameter and how we can draw the equivalent circuit by using S parameter. To show S parameter, we have to consider a two-port network system this is a two-port network, 4 number of terminals, 1, 2, 3, 4, and these 4 terminals are represented by 4 number of variables, that is port 1, which is the input port, that is port 2, output port, the voltage V1, current I1, current I2, voltage V2, positive, negative, positive, negative. That I1 and V1 are the total current or voltage, means it is the combination of both AC as well as DC. Here I or V total is equal to AC value plus DC value. If we plot a graph, so total current or voltage can be drawn. This is the DC value, that one is the AC value. By superimposing these two, we finally obtain the total current or voltage. In case of two-port network system and dealing with that S parameter, here we deal with S parameter. From these 4 number of variables, 2 of them taken as independent and another 2 of them taken as dependent variables. We choose V1 and I2 as dependent variable. Next, V2 and I1 are chosen as independent variable. Therefore, that independent variables we can easily explain in terms of dependent variables. Therefore, V1, that is the dependent variable, we write it as the function of independent variables I1 and V2, I1, V2. Similarly, I2 is the function of I1 and V2. If we consider the small value or small change in voltage and current. That variable we consider in terms of total differentials for small change dV1, that exact differential is calculated as del V1 del I1 dI1 plus del V1 del V2 d V2, equation number 1. I2 exact differential d I2 is equal to del I2, that is a function of del I1 del I1 dI1 plus del I2 again function of V2 del V2 d V2, equation number 2. Look here, from that of expression del V1 divided by I1, that term is known as, this is voltage by current, which is known as impedance, and we write it as H11 1 1. Again del V1 divided by del V2, voltage by voltage, so it is dimensionless, that is dimensionless, in hybrid or S parameter we write it as S12. Next I2 by I1, current by current, again it is dimensionless, next parameter, that is S21. Here I2 by V2, current by voltage, admittance, and it is represented as S22. Look here, del V1 del I2, it is change in voltage and change in current, but when we dealing with AC, in that of AC circuit, the change in voltage or change in current indicates the AC component, because DC as constant, so any change in that of DC will be 0. So the total value of voltage and current here is the AC component, that is AC value. A notation we use particularly for AC value, for AC current, we have to use small I, AC voltage we have to use small v. Therefore, equation 1 and equation 2 can be rewritten as equations 1 and 2 are rewritten as small v1 is equal to h11 h11 I1 plus h12 v2 equation number 3. For equation number 2, I2 is equal to h21 I1 plus h22 I2 equation number 4. And that equation is useful for any mode of operations in transistor. It is useful for all modes of configuration in transistor, like common emitter, common base and common collector mode. Okay. Here we have to evaluate what be the value of these h parameters, and that value can be evaluated by taking such conditions. We evaluate the value of h11 by taking, in last expression it is V2. Taking V2 as 0, V2 0 in the sense port 2 must be short circuited, as a result V2 will be 0. Taking V2 is equal to 0 from equation number 3, h11 is equal to V1 divided by I1, V1 divided by I1, where V2 as 0, and the condition is that output is short circuited, and that quantity represents the input impedance, that represent input impedance when the condition output is short circuited. So, S1 represents input impedance. For that reason, we can write S11 as H I, input impedance, H I. Okay. Next, from equation number 4, from equation number 4 as V2 as 0, so value of S21 is evaluated. S21 is equal to I2 by I1, I2 by I1, whereas V2 as 0, and that term S21 is called forward current gain, current by current, forward current gain, when the condition the output is short circuited. Forward current gain, and we represent it HF, HF, forward current gain. Next, parameters like S12 and S22 can be evaluated by taking I1 as 0. How I1 will be 0? When that port 1 is open circuited. Again, taking I1 is equal to 0. From equation number 3, we obtain H12 is equal to V1 by V2, V1 divided by V2, whereas I1 is equal to 0, and it is called reverse voltage gain, reverse voltage gain, provided the condition when input is open circuited. When input is open circuited, we obtain H12. In notation, we use H reverse as R, H R, reverse voltage gain. Next, for equation number 4, the value of S22 is evaluated from equation number 4. The value of H22 is equal to I2 divided by V2 when I1 is equal to 0, that is known as output admittance, output admittance. Condition when input is open circuited. Output admittance written as HO, HO. Now, the equation number 3 and equation number 4 can be rewritten in terms of HI, HF, HR and HO. Therefore, equations 3 and 4 are rewritten as V1 is equal to H11 as HI I1 plus H12 as HR V2. Equation number 5. Next, I2 is equal to H21 as HF I1 plus H22 as HO V2. Equation number 6. Look, equation number 5 and equation number 6 in order to draw the equivalent circuit. Here V, that is the voltage, HI input impedance means that is voltage by current. So voltage by current into current cancel out, so it is the unit of voltage. Again SR, that is reverse voltage gain, voltage by voltage cancel out, then voltage overally it is the unit of voltage. So the entire term is the unit of voltage. For that reason, in order to show that equation as equivalent circuit, we apply KVL. So Kirchhoff's voltage law is applied. Next, I2 as unit of current, SF forward current gain, current by current into current, that is the unit of current. Next, SO output admittance, that is current by voltage into voltage cancel out, it is current. So overall terms are under the unit of current. Therefore we can use KCL, Kirchhoff's current law. Now to showing Kirchhoff's voltage law and Kirchhoff's current law, again the equations are drawn. The equations rewritten as V1 minus HI I1 minus HR V2 is equal to 0. For that, the circuit, the equivalent circuit we drawn, use KVL. Here the current as I1, the potential from positive to negative, that is V1 as positive, minus HI I1, HI, so a resistor is used as HI, current flown from positive to that of negative. So the sign convention, it is I1. Next, HR V2, a potential source is used, potential source positive to negative, that is a potential source. That of potential source, and potential HR V2. We combine it. So overall we have that equivalent circuit. Next, for equation number 6, we have to draw that of equivalent circuit as I2 minus HF I1 minus HO V2 is equal to 0. So the circuit is drawn. From the current source, first voltage current I2, here the voltage source positive and the negative end as V2 so HF I1, a current source is used, direction downward, HO V2 resistor, that current divided the HO voltage V2, that is HF I1 Now we can combine these two equations to show that equivalent circuit. The equivalent circuit is drawn. Positive to negative, that be the current. Positive, negative, V2 I2 HO, here is HF I1 HF I1, there plus minus V1 I1 HI, here is HR V2, that one is the equivalent circuit. Equivalent circuit by using H parameter. Now to analyzing that equivalent circuit of S parameter, we can replace it for that of transistor, any mode of transistor, either it is common emitter, common base or common collector mode of operations. So here with the help of this video lecture, we understand the concept of S parameter equivalent circuit. First we understood what is S parameter and how S parameter is helpful to us to understand various properties of two-port network system. The S parameter equations, the value of these, and KVL and KCL is used in order to draw that equivalent circuit, and finally equivalent circuit is done. So, with this useful and informative notes, let me wind up this session. Thank you.